Okay, so um, the volume of this shape here, it's shaped by um, graphene, y equals square root 16 minus x squared. Okay, so this guy is this guy here. Okay, only the first quadrant though. We only care about the first quadrant. And it's going to rotate about the y-axis. So the y-axis is a vertical line, so that means it's going to rotate this way, side to side. Okay, so that means it's dy. Um, so anytime you have a graph, so this one's a non-calculator because it doesn't say you use a calculator. Anytime you have a graph that looks like this, we've seen this graph a few times. I think you've even seen it on a test where it's a perfect square, right, on the inside, and you have a square root. It's always going to be some sort of half circle, quarter circle. This one, if I were to actually graph this thing, it would be a quarter circle or a half circle, semicircle. But it only wants first quadrant, so it turns out to be a quarter circle. Okay. Um, so first thing we have to do is determine now we have to find the bounds, and we have to determine the um, radius. Okay. Well, it's going to rotate this way. It's going to rotate this way. That's the way it's going to rotate. So this green is going to come out, go back in, come out, go back in, and create kind of a upside down cup. Okay. Where the mouth of the cup is going to be here, and then it's going to kind of look like that in 3 dimensions. Okay. So the radius is from the center to the edge. So we always start with the edge and come to the center, which the center is always going to be the axis of revolution, wherever it's revolving around. Okay. So this guy right here is this guy here. This guy right here is x equals 0. But since it's dy, what do we have to do before I can plug it into my equation? What do I have to do? Yeah, the first one, this one can't be y equals because it's dy. Okay, this one's already done. X equals 0, already done. Okay, so what I have to do is solve for x. Okay, so let me scroll down here a little bit. So we have y equals 16 minus x squared square root. Okay, I'm going to solve for x now. So first step, get rid of the square root. Y squared equals 16 minus x squared. I'm going to write it a little differently. I'm going to switch them around for a reason. Okay. Add 16 to both sides. Since there's only one x, I can isolate it. Otherwise, I couldn't. But since there's only one x, minus x squared. Oh, 16 is positive. Yeah, you're right. Minus. Okay. Minus. Divide by -1. So I got to divide everything by -1. When I divide everything by -1, that changes the signs of everything. So it's going to be negative y squared plus 60 equals x squared. And then the last thing, I can square it. So we get x equals square root negative y squared plus 16. That's what's going to go in here. So we have square root negative y squared plus 16. Okay. And what would the bounds be? What would the bounds for this guy be? Yep. Top or bottom, left or right, it doesn't matter since it's a semicircle. Okay. All right. So we have to finish this problem. We can't use a calculator on this guy here. The ones I give you on the test will be non-calculator because, yeah, I'm telling you right now, the ones on the test error won't be calculator. They'll be more like this. So it's always good to have practice with integrating by hand. Okay. So how do I integrate this? How do I find the antiderivative? Hmm? Well, yeah. What about the square root and squared? They're going to cancel each other out. So let me rewrite it. Okay. A little easier, so we don't have to deal with the square root. So integrate, like you've done many, many, many times. Good practice. 4 to 0. Oops. Times, so it'd be negative y cubed divided by 3 plus 16y, and I have to evaluate it from 4 to 0. Okay, so pi times negative y cubed over 3 plus 16 times y minus pi times negative cubed divided by 3 plus 16. Okay, the first one I'm plugging in a 4. Second one I'm plugging in a 0. So we get 64. And over here we get pi times negative 64 divided by 3. Over here I get 0, 0, and then pi cancels out. So I have negative 64 thirds plus, or pi, plus 64. If you want to combine them, you're going to have to come up with a common denominator. So the common denominator is going to be 3. So you get negative 64 pi plus 202 over 3. Or this answer too, just depends on which one they're looking for. 192. All right. 192. There we go. Okay, since they don't want a calculator, we're not going to round it this time. That's the exact answer. Most of the times they want the exact answer. So if they want the exact answer, they're not going to let you use a calculator. Okay, so just be prepared to do both. Okay, yeah. Let's see. That's a good question. Let me see. Pi. That's a really good question. Would pi That's a good question. Let me check. Let me check my notes. Nope. Let's see. Notes. Here we go. I can't see it. Must be on different notes. Let's see. Pi over 2. Oh, yeah, here it is. Yeah, I'm not sure. I'm not sure. Let me check on that one. Yeah, that's a good question. Would I have to check to see if the pi would distribute to both terms because there's two terms here, or would it just distribute? Would just multiply? I have I didn't note it in my notes, but I do have the final answer, so I will check it and see. Okay. Okay. So the rest of the time, I'm going to give you guys. I'm gonna post an assignment on Delta Math. I'm going to give you guys time to work on it in class. Okay. Tomorrow, we're going to go on to the next method for volume. Okay.